All right, here we have a question where we're asked for the interval of convergence of a power series. And to do that, we use the ratio test, unless you recognize it as like a geometric, which this is not because that n down there. So the ratio test first has us looking at an expression for the ratio. Okay, so this, and we're hoping you're going to come to this video having some experience with this. So the only thing at risk of being negative is that x minus 3, so the absolute value hugs that. This is my n plus first term. Okay, rather than do division, so again, just a little bit of help. That is that. And then dividing by this, we might as well multiply by the reciprocal. Okay, now we do some division, so I get a 2 down here. That goes, I get 1 copy. Okay, and so in the end, just to rewrite it nice, I have absolute value of x minus 3 over a 2. And then I also have an n over an n plus 1. Okay, what I really want to do is I want to take the limit as n goes to infinity. And I usually take anything out that does not have an n involved. So we note that that limit is equal to 1. So I get absolute value of x minus 3 over 2. Okay, and we want, so the series converges when this happens by the ratio test. Okay, which means that, which means this, which means adding 3 everywhere. Okay, so notice at that point, you get that. And if you look at the answer choices, I think, yeah, so we still have to check the endpoints, right? You can tell because of the inequality. So when x is equal to 1, go back to your original series. You're going to get 1 minus 3 to the n. Divided by n2 to the n. Okay, again, I'm just plugging in 1 into that spot. And this is the same as, okay, so this becomes negative 2 to the n over n times 2 to the n. So notice, just again, notice that this here can be thought of as negative 1 to the n times 2 to the n. And I say that because that reminds you that can cancel. Okay, so I get and this is an alternating series. It either converges absolutely or it doesn't. Does it converge? So I'm being a little bit fast here because this is a multiple choice. Converge absolutely? Well, it would converge absolutely if when you take the absolute value of this, you get a convergent series. And that's not convergent. But conditionally, we just have to check that the non-oscillating part, right? So the non-oscillating part, is that decreasing to 0? I mean, it has always positive and decreasing to 0. It is. So it does converge when x is 1. So that means we don't want that one. And then we just got to check 5. So this problem, they're making you work for it. If you're time limited, just if you get to at least this part, you have a 1 in 3 chance when you guess. But when x equals 5, what happens is you get 5 minus 3. Okay, and this equals 2 to the n over n times 2 to the n. Okay, and then this in the end gives you this. This is not alternating, so we don't need to do a whole. So this diverges because it's a p integral where p is 1. And it's not alternating, so there's no need to do absolute or conditional. So it's just the left endpoint that works. So the answer is B.